Hey, how's it going, everyone? It's Friday. We're going to be going through our final LSTM today. Neva, who gave us some nice updates and actually got it to work really nicely, made a PR, a pull request against our code base. Was it right here? Right here. And so we're going to walk through all of the LSTM goodness, the update that was in the tutorial right here. They're saying, here's a little exercise for you. Augment the existing LSTM part of speech tagger with character level features. Neva was able to do this and got it to work using a pooling technique. Hey, Quantified, good to see you. Welcome on in. Happy Friday. Hey, Saws, good to see you. My brother's back. Yeah, we are. We're gonna be doing some LSTMs today. We're gonna go through all of it. So this is the last day of the LSTM. And then next week, we'll move on to something else. Maybe the Transformer. I don't know. Actually, I'm kind of curious. What is next here? Oh, we're done. Wait, is that it? No way. Wait. Is that the very end? Oh, no. This was just a little adventure, a little side adventure. There's got to be something else going on here. We did some recurrent neural networks things, and then Transformers, maybe. What else are we going to do later? We'll plan this out. We have got some pretty good ideas. Oh, we already did. We did all the activation functions. We might go back through it again. Okay, TensorBoard. Okay, so we need to resume back on the main track here, because what we did was, once we ran into an LSTM, we're like, let's try building an LSTM, and we spent a whole week on it. All right, so we did some building models, TensorBoard, training, and then model understanding. So those are more of the tutorial. Every time we go through these tutorials, we always find something a little bit extra. So we did this. We did the LSTM tutorial, and now we have a pretty good understanding of what's going on here. Steven, real question. Do you get access to Mythos? No. I didn't. No. No. It sounds like I might. I know. No. I haven't. No. They're probably... It's probably an unwieldy model, right? If it's really 10 trillion models, here's what's going on. They can't release it if they wanted to. Even if they wanted to release it, they couldn't, because there's not enough compute available for everyone to use it. It's just too big. It's too big. It would just take too long, and there's not enough. People would have to stand in line for it because of how much compute it requires for 10 trillion parameters, right? What is that? I guess it's like 10x. They barely have enough compute now to host their existing models. So... yeah, what's going there, John Deere? Howdy, everyone. Welcome on in. Happy Friday. It's the weekend. We got to the weekend, you guys. We made it. We made it to the weekend. I'm actually really excited about this. So what we're going to do is we're going to go through all of the LSTM code that we wrote. Steven needs to make a phone call. I know. We can make a phone call. We could. It's fine. Do you really need Mythos? Do you? Hey, Torva. Welcome on in. Happy Friday. We made it to the weekend, you guys. We made it to the weekend. Hello. Good to see you. We're here. All right, let's get on. So the plan for today is we're going to go through all of our code that we wrote over the last week or so, and we're going to review it. And then maybe we'll start on Monday the Transformers. I think that sounds like a good plan. Maybe. We'll find out. Actually, let's take a quick little sneak peek, shall we? Let's take it. Oh wait, that just took me to the. This not a tutorial. It just takes me to the. We can't do anything with this. It even didn't even take me to the right spot. Okay, so here's what we're gonna... defaults, okay. 284 tokens, or 2048 tokens. Made the bot finally work. Did you? That's right, you were asking Kyle for... I saw on Discord, you're asking Kyle for the different Discord users and the YouTube channels. Good idea. The YouTube user idea. That's smart. Good idea. Okay. I want to... oh, here's the paper. Is there a tutorial? It's right here. Check this out. Okay. Accelerating Pytorch transformers by replacing transformer with nested tensors? So this isn't quite what I was looking for. Is this tutorial for me? If you're wondering about building the building blocks of Torch library provides for writing your own transformer layers and best practice, you're in the right place. All right, that might be it right there. Cal has just 2 Discord accounts, right? That's right, 2 Discord accounts. Introducing the building blocks. nested. Okay. This is a long document. Oh, dude, maybe this might be a little bit much. Well, here's the QKV. Why do we have to do that ourselves, though, if they're all the same? And they're just integers? No, that can't be true. They're not just integers. What is this? Oh, they're the size. Oh, okay. Size of embedding. Which should be the same. Total embedding dimensions of combined heads post-input projection. Each head has dimensions E. All right, this seems like it's a bit much. Why would they have even, why have bias here? I mean, it's just such the simplest thing. It should be not, it has a default, so I can't fault it for that. You just made it save in the JSON file, and the bot calls the database. Oh, smart. Use JSON for database. Mark Lemon, hey, how's it going? We connected. We connected, Mark Lemon. All right, good to have you here. You know what? Happy Friday. We made it to the weekend. Hey, Neva, all right, so Neva, we're doing the thing. So we've got your code, we pulled it down, we ran it, it works. Good job, thank you. We're gonna walk through everything. We're gonna do full end-to-end LSTM today. We're gonna walk through all of it. Thank you for the note. Yeah, absolutely. Absolutely. Describe coding in one word. One? Unknown weapon? Just one? Magic. Nah, there you go. Magic. There's your answer. Very good, magic. How's it going there, Michael? Good to see ya. Yep, so we're gonna go through the full LSTM today, the full long-term, short-term memory model. That's what we're doing. Magic. Magic's the answer. Currently just link the text and not the article link. Just change that once we add the Google API. Oh, right. Got it. Yep. Okay, by the way, you don't know if there is a mint... Wait, just did what you tried to do. Okay, yeah, it works. I had to make a few changes. to make it work a little bit better. It works for it. Fine, so watch. Here, watch. Python full. And so we can see that it learns. I just adjusted some of the parameters. And it fits really nicely. Look at the loss on that. Isn't that good loss right there? I think that's a pretty good loss to me. Isn't that beautiful? The real Gibber, how's it going? I've made an LLM. Is that good? You did? Did you really? Did you really make your own LLM? That sounds pretty good to me. That sounds good to me. Whoops. Okay. Let me go back here. Pause this. Loop. It's supposed to loop. There we go. Okay. Got the music going. Yeah, you did, Gilbert. Good job. Good job, Gilbert. You did it. Are you making an AI or something? Yes, I am. The breezy wind. We sure are. We're making an AI. And this is a sample AI. This is like the precursor to transformer, right? This is the LSTM, long short-term memory model. It allows it. We could do whatever we want, essentially, and it's all running on a CPU. If you had to recommend coding language, what would it be? Python. I would recommend Python. It's easy. It's accessible. Everyone can use it. The AIs can use it for you automatically. Or JavaScript and TypeScript, those are the same, similar, right? So those are really good entry points into programming. I'd say Python or TypeScript. Python's a little bit easier, I'd say. Are you still coding by hand? Yeah, we are. We're doing it on purpose because what we want to do is we want to learn as much as we possibly can of the Pytorch ape. We want to be able to learn Pytorch like an expert. Just like Neva. Yeah, so the trick was you needed to think of the shapes. We needed S, W, C, X. That's right, Neva. Okay, got it. And that's why you did the mean pool, which is around here. And right here. The mean pool. Oh, dang, nice, dude. Yeah, the breezy wind, that's right. I think it's a good idea. Is that all of the loss until it stops changing? Yes, exactly. Exactly. It's like how wrong the model is, how far off it was from the target desired output. That's the loss. So we calculate the loss there. And I say that's a really good loss. That's really good. Oh, dang, nice. Oh, wait. Wouldn't HTML be a good start language? Well, is it a language? It's a markup language, so yeah, it counts. It's not a programming language, though, right? It's not a programming language. How did you learn to code? Oh, unknown weapon. When I was 11 years old, my family bought me a coding book because I was like, hey, this looks like fun. You wouldn't look at this giant book. It looks like it's fun. I know, that's what I said. And it included a Borderlands C++ compiler and a CD-ROM. And so I took the CD-ROM, put it in my computer, and I followed on the book. And then I typed it was like, oh, let's type around. It's like C out, and then like these arrow brackets and things. And then put data input for standard input, standard out. Hey, Bonzupi, famous last words. Good to see you. Welcome on in. We made it to the weekend, you guys. What's the plan for when you do complete it? We're going to move on. Oh, well, when we become Pytorch experts, we'll probably start building some fun things. We will. That's the plan. We're going to build some fun things. For apps, Python. For low level, C. Yep. For safe low level, use Rust. Yeah, exactly, Neva. If you want to code fast games, C++ is the best option by far. All AAA game studios use C++. Hey, there's a few, though, that are using Rust, and they're doing pretty good. They're doing pretty good, you guys. If you learn to code at 11, but still do YouTuber, what a shame. Oh, yeah, TC. Hey, how's it going? Good to see you, TC. Hey, we're doing fine. Don't worry. We're doing fine. So if you guys don't know who I am, my name is Stephen Blum, CTO at PubNub. We are Silicon Valley tech company that raised 134 million. Series E, a billion devices on our network. A lot of patents, you guys. What age did you learn? What age did you learn? You learned at 9. 11. I was at 11. Hey, the real Gilbert. You're ahead. You're ahead of me. Please Google Stephen Blum. Exactly. You could Google me. Actually, I'm kind of curious what would happen if you did. Let's see. Stephen. Let's type my name into Google. I don't do this often. Stephen Blum. Let's try this. Google Stephen Blum. All right. Just search. All right. Well, see, it's got a sponsored result. What? Who's doing this? Wait. It's even incorrectly spelled. All right. There's a sponsored result. Oh, okay. So there's a voice actor, but spelled differently. Is there a difference, Steve? I'm not even showing up here. Why is Hugh Jackman showing up? Here we go. All right. We finally got to it. Okay. After no what? That was great. People can enjoy their hobbies regardless of the skill level or success. They sure can, Neva. Exactly. Like Taryn has a YouTube video channel. Oh, see? It can work. It can work that way. Googling yourself can be scary. Yeah, fair warning. I know Bonzoop is what just happened. But AI also end these. Did they? Well, technically, yes. Technically, I mean completely, yes. Completely. Studio Ghibli. Oh, yeah, Studio Ghibli. A bit more famous. I think so too, Michael. Yeah, I think so too. I'm with you on that. Do Stephen Blum PubNub instead. Yeah, there you go. PubNub. Now you'll get the right Stephen. There you go. Hey, no, we got him. Quantified Quantum. Thank you for the correction. You Google yourself and you're the first result. Okay, good job. That's awesome. You did good. That's why they showed up. Studio Ghibli. I'm with you on that. All right, let's get into some of our code here. So what Neva wrote, so you see Neva in chat here. Neva wrote this. This is Neva wrote the LSTM updates, and we are going to review them today. We're going to go top to bottom, front to back. We're going to do that. All right, here we go. I want to close that window, and we're going to start at the very top, and we're going to walk through this entire code base. We're going to walk through it all. We wrote all this live on stream, and Neva applied some updates for this task tutorial, which we had around here somewhere. Where is that? Was it around here? Was exercise, yes. Convert the LSTM part of speech tagger with character level features. And Neva did that with a pooling using the mean of one of the dimensions. You got a weird name, Bonzupi? Well, if your name works, it works. You've got SEO. You've got SEO rank on it. You Google yourself and there's no result. Anonymous. Right? Really? No. That means that you don't have a web presence, and you probably did that on purpose, right? You're intentionally. That was Hugh Jackman showed up because they were on the same film for voice acting. Got it. Yes. Okay. Okay, Michael, that makes sense. All right, let's get back to our code here. So let's walk through everything, you guys. Let's walk through it all. So we're importing Torch. We're getting ourselves a nice little easy accessor to the neural network part of Torch, which is where we're going to define a lot of the components of our model, right? It allows you to create tensors or tensor layers, so that way they're pre-set up with all the configurations that are necessary in a tensor to include like back propagation, right? To allow gradients, to allow computing of gradients and tracking of the inputs and outputs. Functional.f has some additional like easy access, you don't need to instantiate anything, right? With the functional, it's ready to go easy access functions. So they're not like instances of, you can just immediately call them, which I think we did that with our softmax, right? Softmax. Yeah, right here. Oh, we didn't even, we imported it. All right, let's use that. We imported it as F, but we didn't even use it. All right, so there. All right, I fixed it. That was great. Let's see. Are we using it anywhere? Okay, so the only place we use it is right here. That's the only point. Like, there's no need to import this F. There's no need. You're thinking of making an HTTP spec compliant server in C. Hey, Quantify Quantum. Have you ever made one? Yes. Well, not like a fully compliant spec. Just a few smidgens of it, right? Like post and get, head, options. That's about it. You don't really need more than that, right? You can support just HTTP 1.1, which requires you to have a host header. If you want to support HTTP 1.0, there's no host header. You're required to include the host in the path. That's the difference. So yes, I have made one, just not fully spec compliant. Oh, thank you for the party poppers. Thank you. Thank you for the hearts. You know what though? You know what? You could probably have the AI write that for you in 10 minutes. Especially now with Opus 4.7. Have you guys tried it? It's noticeably better. It's noticeably better. I mean, if you can achieve the same thing with 4.6. If you have 4.6, 4.7, you can do the same thing. Oh, hey, 1C, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We do AI. We're doing a lot of AI in this channel. We want to become Pytorch experts. That's what we're doing. You're scared of creating a cookie header parser? It's crazy how much it can vary. Yeah, there is a challenge. And you also have to worry about max header parsing sizes, because you can stack and pack headers so much that it overwhelms the server. Jacob, how's it going, Jacob? Welcome on in. Good to have you here. All right, let's go over our LSTM, you guys. You haven't tried 4.7 yet? You're poor peasant models like Minimax. Those Bonzubis, those are good too. They're good. Hey, Kyle, good to have you here. You'll be using Gemini Fast with API for CLI because it's good price. Yeah, there's not. And exactly, it codes really well. I'm with you, Kyle. Gemini is fantastic. It's fantastic. Hello, everyone. Abdurasul, welcome on in. Hello, Steven. Good to see ya. How's it going there, Ray-Ban? Ray-Ban 2, good to have you here. Or X-Ray-Ban, right? X-Ray-Ban. How are you? I'm doing good, Jacob. Thank you. It's Friday. We're at the weekend. I'm so excited. I'm ready to, we've been burning a lot of time. Are you guys, here's the deal. Check this out. All right. Now with AI, for those of you who you work in your job, or maybe if you work, and now that we have AI, before AI, we'd work really hard. We'd like have sessions of like intense moments of coding. We'd be typing a lot. However, now with AI, I feel like we're working a lot more. I feel like we're getting more done, but we're also working a lot more. And it's fun too. Are you feeling the same thing? I feel like I'm having a lot more fun with AI writing a lot of the code. It's sad that AI will kill software engineering jobs. It'll half of the demand for software engineering, considering now one person can do like 2 to 3 people's jobs in the same time frame. Yeah. Well, here's the deal. So I heard Jensen Huang said that we're now limited by our imagination. We're at the bandwidth limitation of our imagination. Where's the next bottleneck? Right? What's the next bottleneck? So businesses that have objectives in software engineering goals can now achieve that a lot more quickly, so much more that they are now at the limit of their imagination. So now what we need to do, we need to automate imagination. Right? We need to automate imagination. That's what we got to do. Your dad says hi. All right. Well, hello, Dad. Hello, Wake. Good to have you here. Steven, want to announce the upcoming video series topic we talked about yesterday? Let me see if I remember. Oh, yes, on the live. Okay, 1 second. Whoop, no. Oh, darn. I didn't mean to move that window. That window is going to stay right there. Okay. All right. I meant to move the Discord window here. All right, quantify quantum. Let me see here real quick. What do we talk about? I know it was part of the plan. I know that's part of the plan. Let's see. 1 second. Where did we say that at? If you could remind me. I'm going to scroll up here. Good idea. All right. Okay. AI assistant handler that passes the call to you if it's important. Otherwise, it tries to answer it. We can basically give access to your schedule. All right. Yes. Okay. So that is planning. That'll happen. That'll happen. I do have a plan for that. Whoop. You saw nothing. You saw nothing. Okay. Whoops. If you're a polymath, it's a boon. If you're a specialist, it's not. Well, I could think. I could see where that is. Hey, Danny, how's it going? What's your opinion on learning to code in this age of AI? I think it can help. Is it required now? It's not. It's not required. Does it make you better? I think it makes you better. Though, is good enough good enough? It might be. You might not need to know this anymore. What are we even doing here? We've got code on the screen. What is all this? Do we need to even look at this anymore? Have you made any games? Yes. I've made some games. Are they good games? No. Are they games that I would release to the world and have people play it? No, not even that. I've made games though. I think it's still worth learning to code. With AI now, you can do the same job. Yes, 2 to 3 times faster and needing less people because AI assists them. It sure does. I love it. I use it all the time now. Vibe coding is the hype now. It sure is, X-Ray Band. You're right. Right now, we need engineers that know how to audit the work done by LLMs. Bunzupi, yes. The current LLMs, they're good. They do a good job. And we've written entire projects using vibe coding approach, fully AI generated. We're finding all sorts of little hidden secrets inside that code. After many, many, many months of development on a project, fully vibe coded, there's always like little hidden secrets that you didn't know about. Has anyone else done this? Hey, Zergio, good to see you. Welcome on in. What comes after REST API? What do you mean? What do you mean? What comes after REST API? What is inside of a REST API? Usually a database, something like that, like on a common perspective. You need to look at it. You need to understand it. Not because you need to execute. It's just something different use, same thing, different use case. It's good to understand it. I think it helps a lot. We need people with discipline and real skin in the game. Otherwise, there's no accountability. And we end up with vibe-coded apps with Swiss cheese threading model. Yeah, but it works though. Read the comment before. All right, Michael. Let me see. Let's see. Where are you at? It might not have shown up here. I don't see it. Maybe you meant right before that. Right now, no. It's not showing up. I don't see it. You see, I see here. So I see you here said what comes after REST API, and then I don't see anything else. It might not have shown up. Oh wait. Oh, so I just got back from. Oh, wait, that's not the same, is it? No, it is. What are you saying here? You just got back from Portugal, and they are very behind on AI. That's the last message. I don't know if they connect up. Or not. You'll send it again? Okay. It might not show up because YouTube is very good at removing some chats that seem legit. We don't understand how these patterns are overlaid. To accomplish the task, all we can do is reinforce good decisions. There you go. Hey, Aziz, welcome on in. You think the future for AI prompting is more promising? Engineers who are good at AI will be hired and win the competitive over... Yeah, they will. They're going to win it. Engineers who are doing it the traditional way. Absolutely. Everyone now, who's going to write any more code by hand? You're all going to have... Well, we are right now because we're learning a framework. We're learning a framework right now. So I still think from a learning perspective, writing code helps. However, have the AI do it now, right? Right? Have the AI do it? I think so. All right. Reinforcement learning is essential to both humans and AI. The good old reinformant. What is reinformant? What is reinformant? Reinformant. Do you mean reinforcement? Is that what you meant? All right, guys, let's get back into it here. Let's go to our code. Let's walk through the tutorial. Import Torch, import the neural network. We don't really need that. We don't. There's no point. I'm going to get rid of this. We're just not using it. All right, clean up. Optim for our optimizer, which we also don't really need either. Right? So we could just say, oh wait, we're not even using it. Let's get rid of that too. All right, we just cleaned up a little bit of our code there, you guys. Cleaned up a little bit of code. You've noticed that AI is not great with what comes next. Imagination. For example, what comes after REST APIs, or what's the next new protocol? Oh, that's what you mean. Okay. So there is an evolution, and it's called gRPC. That's an evolution, right? It's not a revolution, it's an evolution. It's like what's after a REST API? You got gRPC, which is over HTTP 2. It is just a next up, right? Because REST is over the top of HTTP. Well, gRPC is over the top of HTTP 2. So the answer is gRPC, right? Could also work on H3. Okay, let's get into it. All right, so we got our dictionary, we got our tags. Happy Friday, you guys. It's the weekend. But then there is HTTP3. Yeah, exactly. Now we got H3. Dictionary tags. So our dictionary is going to be our tokens. This is our tokens. Let's read this. This is our tokens. We're going to have word level tokens. We're also going to have... Wait, did we change this? We changed it. So we migrated it to letter level tokens. Letter or character level. Oh, how's it going over there? Thank you. High Potential. Oh, you're over there on Twitch. Hey, thank you for joining on in. Good to have you here. Happy Friday. We're at the weekend. It's so exciting. Letter level tokens, right? So that's what we merged it to. And then this is our target output tokens, which is going to be word classification, right? Classification. Let me spell that right. So that's what that's going to be. This is what these two items are. These are our tokenizer. These are ready for a tokenizer. So we need to build our tags and build our dictionary. And this was the word level dictionary builder. Build dictionary word level, which I believe we no longer are using, right? We're not using this, so I can just say that. So this is what's called dead code right now. You think the model still needs to be trained on bad code at least so it can learn what bad code looks like. Oh, I hadn't thought about that. That could work. I'm thinking about that for a second. Do you want to train it? So you do. Okay, so you're right. However, it's going to go in negative reinforcement. So you train it on bad code in a way that updates its weights in the opposite direction, so it knows not to go down that path. So you train it on a reinforcement with bad code examples that negate, like reverse. Instead of adding into your weights, you'll subtract into them, I think. Something like that. Steven, yeah, the basic tricks, the data cleanup is different. Basic trick. Oh, got it. Yes. Okay, got it. Yeah. Neural networks are designed to capture intricate patterns, exceptions, and deep contextual nuances. You can get, yep. You're on a few papers? Am on a few papers. You are. If you Google me, no way, really? Oh, I'm so excited. That sounds great. Okay, on Arvix, yes. Arcs, or what do you call it? Arxiv? How do you say that? I know it's a place where a lot of papers are, like the white papers. Arxiv. I've seen a lot of these. Yeah, it's basically a giant repository of white papers. Enlighten us, Neva. It's pronounced archive. Oh, Bonzupi, thank you. Archive. I never knew. Really? Archive, right there. Oh, thank you. Like archive. Archive. This whole time I've been calling it Arzib. All right. Now I feel like I'm on the inside. I feel like I'm on the inside now. That's great. Arc-IV. Yep. Archive. Archive. Yeah, it makes sense. It makes sense to me. And the Arxiv. Okay. All right, so we made our dictionary here with a mask that says this is something to not pay attention to. I know that we can also update our LSTM to ignore a certain token. Do you guys know how to do that? We didn't update our model to do that, and I think I want to. So that will be a to-do today. To-do, update LSTM model to ignore token 0. We need to do that. Okay, that's done. Neva, I fixed a few things. Your output classes on your... Well, I mean, this might have been my fault. This might have been something I did. I found a bug right here. When we deleted layer 2 on the output, we needed to update the hidden dimensions to be the number of classes. So I did that. And I think that was like the big one. That was the only thing. That was the easy one. And then I also want to update the LSTM to ignore token 0, and I don't know how to do that. Resume or resume? It's one of those two. How's it going there in Pulsar? Oh wait, how's it going? Hey, it's nice to see you again. Welcome on it. It's Friday. Isn't that great? Have you guys played Crimson Desert? I'm gonna play a little bit of Crimson Desert this weekend. I'm really excited. It's sort of like Breath of the Wild and Red Dead Redemption 2 at the same time, because you've got, or the Gelu. Yes, that is a activation function. The Gelu is an activation function. You did labels on purpose as words because word level, I thought that's what you wanted. Yes, it was, right? Did I do that wrong? I wanted, so we're doing word level classification. So we need the word level. So you get the letter out, and then you convert them into, I suppose, words. And so I'm not fully sure how this works and how it looks. From the input, from the embedding of the sentence, which is gonna be characters, right? These are gonna be a bunch of characters here. So these are letters, letter tokens. There's the letter tokens here. And it doesn't know what words are anymore. So we still wanted to classify our output to be our targets. And in the code it had that. I think that was just a typo, or because we got rid of L2 here. Right? Does that make sense? We then move 1WZ. Shape starts as WCX. Oh, no. It's letters grouped as words. Look at it. Yes. So I figured as much. And they're not the actual words anymore, right? Right? They're not the actual words, are they? Are they? So you're now training both. Yeah, exactly. It's capturing letters and then it's converting it into a word LSTM. They are the actual words. Oh, really? Oh, Naveen. Hey, Naveen, thank you for subscribing. Welcome on in. Good to have you here. Happy Friday. We're at the weekend. Are you sure they're the actual? They match 1 to 1? So are you sure? Because when I did my tokenizer for the letters, I didn't take into account the words. So unless you fix that part, it's still got to be on the letter. Oh, you're grouping them as words? That's the input management thing you did. Okay, I got to check it out. Oh, Melodious. Hey, thank you for following, Melodious. Good to have you here. Appreciate it. Yeah, you deleted your tokenizer. Oh, you did. Oh, okay. Oh, so you're not using this? Oh, you're not. Oh, okay. Well, that explains it. You delete. Okay, so it's not using this anymore, and it's not using this. So I want to keep them, but you decided a bug. It's a bug because you can't create an output as words. Yeah, exactly. You couldn't. And labels were per word. Okay, so you fixed that. All right, I need to figure out where you did that. So you already took that into account. Your brother said hi. All right. Hello, Jacob's brother. Good to have you here. Welcome on in. Happy Friday, you guys. What's up to your brother? Exactly. All right, so where'd you do this at? Vectorize. Okay, so vectorize. Normalized. Okay, I saw this. I remember seeing this here. I saw that, and so we need to walk through that. Where you put that in here, because this is new. The vectorizer is basically what took over. It took over for the features and the labels as well. Yeah. Okay. Do you prefer SGD with momentum? I do like my stochastic gradient descent. Soaky. I like it. Add momentum, which modifies the learning rate over time, right? It modifies the learning rate over time. It's pretty good. I like it. It seems fine. It's my go-to when I'm writing my own from scratch. Okay, so let's take a peek here. Let's take a look. So you've got normalization here, and then you've got features, which is going to do character level features per word. Let me print out the features and see what that looks like. All right. What we're going to do next is we're going to print these out and we're going to return so we see what we're looking at here. Python full. There we go. What do we look at? Oh, no. It's not supposed to train. Why did it return? Why did it train? Did it not save? Okay, there we go. This one I'm looking for. Okay, here we go. So we got our features. Yes, never. Yes. Okay. I see it. Here's the word the right there. And the word, was it dog? The dog ate the apple. Done. That's it. That's the first sentence. Okay. So you've tokenized the letters. This makes a lot of sense. I got it now. Okay. So every letter is a token, and every one of these, what do you call them? Lists, all these lists here is a full word. So we've got the full word going on here. So each of these arrays is a full word. Okay, Neva. It makes sense now. It makes sense now. Oh, this is really good. Oh, I like it so much. This is amazing. So we've got these. So essentially, this gives us the ability to assign meaning for each of our tokens. Each of our tokens has more meaning. Instead of being a one-word token, we've got an array of letters representing our token, right? So each of these arrays here is a token. Each of these lines is a token right here. So that's a token, that's another token, here's another token. And they're all represented by the tokenization of a letter. And we only have so many letters. And our letter tokenizer, let's see here, our letter tokenizer looks like this. Where's that here? Here's our letter tokenizer. Right there. Using 100% of the alphabet that we have present in our data set. I like it. Neva, thank you. This is great. Okay, let's get back to our... It makes so much sense now. So these are unused. This is dead code, right? So we're just gonna comment those out for now. We don't need any of these here. We don't need any of those. So those are hidden. We should still do this though. We should still do this one now. How's it going there, Dashi? How do you debug exploding or vanishing gradients? Well, first off, it's very important that your input data and your output targets are numbers between 0 and 1. That's a very common thing that I often forgot to do myself. When you're inputting data into your model, you want to make sure that you've vectorized them or normalized the numbers so that they are between 0 and 1. Now, you may have noticed in our LSTM here that our numbers are bigger than 0 to 1. That's because our LSTM is expecting tokens to be indexes for values that we're representing in the meaning, which are our character level. I took that as a mistake and intentionally brought those numbers into the space between 0 and 1. However, the AI for the LSTM is like, no, you didn't want to do that. Nope, you got to put them in token format. So that's why you're seeing those here. So there's some, and if you're using a framework like Pytorch, it might help you out up front. So you can do things like this. It does help you out. It is actually kind of nice. I do like it a lot. I think it's great. So that is number 1 for exploding and vanishing gradients. Make sure your numbers on your inputs and outputs, your targets, your features and labels are numbers between 0 and 1. That's very important. So it could be straight up 0 or 1 or in between, however you want to vectorize your data, right? So that's important. Next, obviously, to prevent exploding and vanishing gradients, you're going to be using activations. Those are non-linear activations that allow you to prevent the numbers from going too big inside of your model as they're passing through your parameters. Could you activate it? Oh, how's it going there, Bullock Duku? Wait, hold on. Bulu Kuduku. Oh, Bulu Kuduku. Bulu Kuduk. Oh. Hey, thank you for saying hi, at least. Wow, well done, brother. Well, thank you. Yeah. And that's just part of it. We're not even done yet. There's a lot of other approaches that you need to take as well, because you want smooth gradients, right? You want your gradients to be smooth so they can generalize and identify data correctly, classify it on things it's never seen before, right? That's what you want to do. So you embed the characters and words, vectorize, and map to sentences, basically. Yeah, Kyle, exactly. You got it. That's what we're doing here. So you can see right here the word the, T-H-E, right? T-H-E. And if we jump up here to our word mask, you can see the letter T is number 1, H is number 2, and letter 3, E is letter 3, right here. So you can see the, T-H-E, right there. Neva, this is awesome. This is really neat. You changed my world today. You changed my world for using LSTMs. You brought me from a little bit of understanding just now from the last week to the next level. Thank you. Neva, thank you. It's a lot of the I'm a result of bad function choices for activation or cost. It's a lot of the time. Oh, a lot of the time, a result of bad... Yes, okay, yes. So you can have exploding gradients or vanishing gradients if you choose incorrect activation functions. That's also part of the picture. You need to optimize for that as well. And embedded means turning them into numbers. Yeah, so let's go through the embedding real quick. Let's do an embedding here. So they are already numbers, but embedding is going to put it through a higher dimensional. It's meant to reduce the dimensionality, right? Embedding takes meaning from words and it simplifies it into a lower dimension, right? That's the output from an embedding. You were going to tell you that as well. He just beat me to it. Oh, Mark Limit. Yep. There you go. Yeah, so it does turn them into numbers. You're learning farming. Oh, really? And you're using Google Colab. Kindly suggest some open source data sets related to value-added products. I know decision tree algorithm. Wait, you're learning farming. What? wait. You gotta explain that. You gotta explain that. Wait, why in farming are you using Google Colab? I think you meant you're learning AI, machine learning, and you're using Google Colab on servers for the notebook, right? You know, decision tree algorithm. You're still trying to wrap your head around it. Me too, Kyle. Me too. I want to get so good that I just know it end to end without a second. And I'm going to spend as much time as it takes to become an expert. You have already done model merging. Oh, really? You've done model merging? In what way? I'm actually kind of curious. So you've had you stacked models, taken input from one model and put it into another, or you've updated the layers, you've changed the layers, you've merged the layers. I'm actually kind of curious. What did you do from that perspective? I'm actually kind of curious. Tell me more. Tell me more. Don't let me hanging. Coding can be fun. GK, well, it can be. It can also be a problem. It can be a problem because you can run into situations. All right, so let's look at our embedding real quick. I want to investigate that. So let's print out the embedding, print out. And let's run through one layer. So we got our model here. And I'm going to run our training data through it once. So we will, let's see here. Where do we want to do that here? Return. We'll do this. We'll do this. We need this right here. We'll run through here. I'll just do a return on the output. Model sequence. Print out and return. So we're going to go through one. We'll go through one. We want to print the full output. We don't want to print the full output. I just want to run the model through once. So LSTM, right here, we're going to return the out. Oh, actually, that's perfectly fine. Perfect. Okay. So let's run that. Let's look at what our embedding is. Build tags is not defined. What do you mean? Oh, did we need? Oh, we still needed the build tags. Okay. Tags. Where's that at? Build tags. Okay, so we still needed this. Okay. Boom, right there. Right there. You so happy about this? Me too, Neva. Thank you. You blew my, you expanded my mind. You expanded it. Start with some seed and exactly in Pulsar. Exactly in Pulsar. That's what I was thinking. You copy layers and merge them. Oh, okay. That makes it a little bit more. Understood. You'd say coding is both a fun problem. It is a problem and it's fun at the same time. Don't mention it. Thank you, Impulsar. Thank you. Thank you for that. Gemma 4. Oh, yeah. See you all in the Gemma 4 hackathon. Oh, sounds good. Is there a Gemma 4 hackathon? That sounds great. CNN trained using icing simulations. Huh? Oh. I don't know what an icing simulation is, though. I do know what a CN is. I get it. Steven's so positive it's contagious. Never you. Well, I'm telling. Yes, exactly. There's positivity in here and I'm letting it out. I'm letting you know. My real feelings, my real true feelings. Oh, what's the French word for expanded mind? How do you name that feeling? Yes, a revelation. Is it revelation? It detects temperature fluctuations in physics simulations by how much the Mo rotor panics. Wait, about which expert to send an input to? It's not epiphany. Oh, epiphany. Right, so epiphany is when you have a moment of realization that just like, whoa, it's profound. Like, hey! And maybe like a little mini epiphany, right? You know, just a smidgen of an epiphany. The Dreamer entered the chat. How's it going, The Dreamer? Welcome on in. Happy Friday. We are near the weekend, you guys. All right, so let's take a look at our embedding real quick. Okay, so that turned it into a bunch of numbers between, for the most part, between 0 and 1, right? So that you can have numbers like up to 3. That's fine. That's also something I did in some of my models. I'd allow numbers between negative and positive 2. Wait, positive 2, negative 2. I'd allow that. And so it seems like that's also happening here in the embedding layer. If I'm looking at this correctly, so we've got a bunch of words here, right? So look at all our words. So we've got a sentence here. So here's one sentence, and it is a 3-dimensional sentence, right? 1, 2, 3. And then our embedding output, 1, 2, 3, it looks like it's just giving us a projection. Expanded your mind is a little different though. That is true. That is true, because you can expand your mind in all sorts of fun ways, right? Your thing the same? Like, now we'll meet on Monday. Exactly, it's gonna happen. It'll happen. Okay, let's keep going, you guys. All right, so here's what I want. So it's not exactly what I was thinking. It just took data through a layer as far as I could tell, right? Is that all I'm looking at? Is this all I am looking at? Oh, wait. Oh, it does a little bit more than I thought it would. Well, okay, so I see one. So here is, so this is a full, is that a full sentence or is that a full word? What is that right there? How do we compare this? Clairvoyant. Clairvoyance is an ability to see things, right? That are not in front of you. Is that what that is? You can see things that are outside of your current human level perception. Is that what clairvoyance is? What is this? Is this a sentence? Is this a sentence? What? How did so the embedding output just transformed our input into a different dimensionality in the output. So we've got this embedding dimensions here, which we set up as a fixed size. I believe we set it to 12. Okay. So what if we set this to like 3? Can we do that? Jello, hey, it's Jinlu. Good to see you, Jinlu. Welcome on in. It's the weekend. I'm so excited. I'm gonna play some fun video games. Let's change the embedding size, you guys. All right. There we go. There we go. Okay, so 1, 2, 3, 4, 5, 6, 7. Why are there 7? Why are there 7? 1, 2, 3, 4, 5, 6, 7. Oh, is that because that's the length of the sentence? Oh, we're seeing some shapes now, aren't we? Steven, I'm pretty sure you're missing a few conv linear layers. Are we? It seems to work. It seems to do the trick. I think like either physically ability to see good or a mind with the better insights. That's what I thought. Okay. Okay, so you can have clairvoyance to see better than physical ability. Got it. Serious eye bags on someone who didn't sleep last night. Oh, in Pulsar? Well, sleeping does help a lot. It sure does. That's right. I know, right? Dreamer, you changed your name and this is the final? I don't believe it. Nope, because you used to be RUX 10,000 and then you changed it to Claude. And then you were something before RUX 10,000 as well. I don't think this is the final time. You made PubNub account today. Oh, Kyle, that's awesome. And you all should too. Yes, make a PubNub account. That's I'm excited for the weekend as well. My AliExpress packages are probably arriving tomorrow. Nice. I bet you have some hardware, right? I bet you have some like boards of some sort, right? Some sort of microprocessor in there maybe, right? I bet you do. Another ESP or something. Also accelerator work here for the issue. For this use, accelerator work here. Yes, we could. We don't need to though because it's a small enough model that it actually performs perfectly fine on a CPU. All right, let's keep going. Okay. So this is our inputs here. And then on our embedding layer, it's taking that and converting it here into, 1, 2, 3, 4, 5. Interesting. So I'm just like reviewing this. 7. Okay. So it changes the whole, it takes a picture of the whole sentence. And the input sentence is the length of 7 tokens. And so our embedding output is giving us 7, essentially 7 words at this point. That's what we're seeing here as an embedding space here. Already have one, Kyle, and used to fill up your project during testing, so you made another one. Ooh, nice. Oh, that's right, the Dreamer. Yep, we'll return, and someday copyright it. Well, if you have to change, you have to change. Some prototype PCBs. Did you build some prototype PCBs? LCD display for USB. Nice. USB-C to USB 2 or USB-B, right? Adapter and a joystick for your ESP. You got a joystick? All right, as soon as you get those, definitely put those on Discord. I want to see what you got there. What's with not having access to prod keys right away? Oh, it's fine. It's actually fine, Kyle. Little secret. You don't have to worry about it. It looks like it. It's the same thing. Don't worry about it. Don't worry about it. It's actually not a problem. It's not a real problem. The keys definitely will. Nice, Jinlu. Thank you. It's a little secret, Kyle. Don't worry. It's actually okay. What the heck? I know. It looks like it's different. It's a little secret. It's an inside secret. Don't worry. They're the same thing. It's the same thing. I know. There are some like per rate throttle limits on the test key. You won't hit them. Though. You won't. They're like millions and millions. It's up there. It's just in case of accidents. So you're fine. Don't worry. It's the same thing. You're perfectly fine. You're good. Don't worry about it. Okay. So this is the embedding. That looks really neat there. Oh hey, Yo Trip. Hey, thank you, Yo Trip, for subscribing. Welcome on in. You joined the right channel for software engineering. What we do on this channel is we write code by hand as we learn AI. That's one of our big projects right now. We are learning how to become a Pytorch expert. We're going to learn everything we possibly can about Pytorch, end to end. And I want to be able to like handcraft any Pytorch model without referring to documentation, maybe a few doc lookups and things like that. What language are we coding? Hey, Mike Green, welcome on in. Good to have you here. Pytorch. Yep. Okay. You got it. Yep. Exactly. Python. We're doing some Python, you guys. Okay. So I want to switch this down to 1 so we can see what that looks like at 1. Okay. There you go. So we take our input here. 1, 2, 3. Wait, let me count this real quick. 1. Here, I've got a better idea. Let's just change how we are splitting our screen. You can see it over here a little bit more easily. All right. 1, 2, 3, 4, 5, 6, 7. So I see 7 in here. And each of these is representing the, because 1, 2, 3, 4, 5. So 7 is the length. It's just the view is interesting because the length of my max word size is 5. And the sentence size is 7. So 7 words, max word size is 5, right? You hit your, different user limit while testing because I had to connect like 30, 40 devices. Oh, you've been getting through Python, CSS, and HTML. Mike Green, nice! That's fantastic. Those are great things to get started with. What is potato PCB? Because people say, I have a potato PC. What does it mean? It means a slow, clunky, underpowered PC is what it means. Potato PC means slow, underpowered, old. That's what it means. You just have old hardware, dreamer. Yeah, exactly, Billy Bob, exactly. Exactly, Billy Bob. All right. It means you can run Doom and that's it. Exactly. It can run Doom. You're good to go. Nothing else you need. You have a beast. It's an Ubuntu. Nice. So the graphics drivers aren't as good as they can be. Linux graphics drivers may want to do Wayland. Oh, that sounds pretty good. Wayland. Yes. Wayland is optimized for GPU, right? Wayland is optimized for GPU. Right. Wayland Linux. Modern, secure, high-performance display server protocol designed for thank you for joining in, Chitty. Welcome on in. Good to have you here. Thank you for subscribing. Appreciate it. What are we doing here on our smoother graphics, better multi-monitor support, and improved scaling? Nice. Most desktops can do that, which is, you've got a good graphics card there. RTX 4090. It is ridiculous. It's a really good one. NVIDIA drivers have gotten really good for Linux in the past few years. Well, if you've got an NVIDIA RTX, your RTX right there, you'd want to use Wayland. Nice. Okay, so I understand the dimensions now. So the thing is though, this is only one sentence. Okay, so this is one sentence here. So we've got 7 words and 5 letters. There we go. It makes sense now, doesn't it? Yes, it makes sense. So you can use an embedding model to expand or contract your embedding space. I'm actually kind of curious to see how this will perform. Let's comment some stuff out here. Where are we at here? We don't need that anymore. I think we're good now. Okay, print, go. All right, let's try that. All right, so it's gonna learn. Oh, it's having a hard time learning now. It is learning though. Oh, no. Oh, it's going. Okay. Even with the smaller output embedding size, it's doing all it needs to do. So we never needed that much upper level dimensions. We didn't even need that much. So we just optimized our model, not only in performance, but accuracy and speed and training, just by reducing our embedding. Right here, our embedding dimensions, we reduced it. That works for me. Me on Monday, bye. All right, Dreamer, sounds good. Good to have you here. Oh, well, you can get a better monitor though if you want. I mean, if you have an RTX 4090, a good monitor is necessary to pair with that. No more slaving over obscure docs to find that magic configuration to get your Optimus drivers working. Bonzupi, are you saying that because... Oh wait, why is that? Oh, because of Wayland? Or because we have AI now? Huh? You had the money to buy one, just wanted to do it. Yeah, exactly, there you go. A 4090 for work. Oh, got it. To run AI, yes, got it. Okay, I figured, not to game. Gaming is just a happy consequence. Yeah, yeah. Yep. Oh, don't worry, this is just for research, right? It's just research. Okay. So what if we switch this up back to 6 real quick? Are we gonna see anything a little bit better? Is it gonna be smoother? It learns a little bit more readily. I think we could probably get away with 3. Okay. This is neat. This is really neat. I'm understanding the shapes now. In my head, I can see the patterns. When I close my eyes, I can see the 3D shape of the tensor. What the words and the letters look like. I can see it now. You made some research code in a published paper. Run it on that machine. Oh yeah, there you go. You just provided, what do you call that? Justification. That's the word I'm looking for. Justification. Whoa, Code Langtons! Hey, it's good to see you. Welcome on in. Whoa, that was amazing. Thank you, Code Lang. Thanks for the 550. Whoa, that was amazing. Appreciate it. Thank you. Exclamation point. Party popper. Whoa, Code. My gratitude to you. That was very awesome. Thank you. Appreciate it. Look at that right there. This is what I see on my screen. I see like this giant message right here. Code Langtons. Thank you. To justify spending money for research. Yeah, exactly. I used to require a convoluted X11 configs to get the hybrid graphics between GPU and the dedicated GPU working properly. Well, apparently we don't have to worry about that convoluted config anymore, right? Turns out any serious AI work, they give you the correct hardware anyway. Hey, it works either way. Code Langtons again, thank you. What is crucial for energy efficient on your laptop? Oh, it is crucial for it. Yes, I got it. Okay. Code Langtons, thank you. Love you, man. You're so supportive. Well, I appreciate it. You're supportive. You're so supportive. That's fantastic. Oh, I'm so excited. You're certified collab dev on Google. The good old Google collab certification. You saw it the other day? Nice. All right, so that's what that looks like. All right, now that we've understood that, I do want to learn how to do this. So let's take a little detour here and work on this. So we can update the LSTM model to ignore a token. I need to consult the internet for this. And since I don't want to jump into a web browser, I'm just going to go here and say Gemini. I'm going to say, I'm going to ask it to not do anything on any of my files. I just want to ask it a question. We're just going to say how to do it. Instead of looking up docs, we're just going to do this ourselves. Okay. We need how to set ignore mask/padding tokens in LSTM Pytorch. I'm just curious what the config option is. You saw it the other day. Would you look at this? Clips, the guys. This guy is rare. You put a quick link in general. Oh, Jinlu. Okay, we'll check it. We'll take a look. Wow, the AI is thinking. Oh, the null. Right. The null. What was it? I can't tell. We can only make this so big. What was it? What was the null? I remember you had this the other day. What was it? You had the null up here. It's not null anymore. Or is it still null and it's whatever this is? Because null just means that you don't have any, there's no title header, right? You're missing a config line. You just need a config line. Welcome. What is it? Welcome. You have question mark unread emails. What is that? What is that? You'll have to ask a friend of yours at some point to put in a good word for me at his firm he works at once I'm done with dual study. Nice. He got a quad 5090 PC, a quad, 4 of them for work. Wow. That is a bit much. No, title header is set to null. Oh, it was. Okay. Well, that'll do it. That'll do it. All right. So it was just set to null. It's finally EFI shell with a custom startup script that just echoes and delays. Oh, all right. Well, I see some arch. What is that? I see something that looks archy. What is that here? Absolute solver. Override detected. What is this? Critical error. Administrator CYN has bypassed firmware. Waiting for result. Solve. All right. I've not seen that kind of message before. He needs one for his actual work, but he has a great gaming rig to. Yeah, he sure does. Got to try it out once at least. Yep, you want to see what those frames per second are? You sure do. It's the drones themed. Oh, is it? Okay. Got it. All right. So how do we do this? This is a little bit mushier. I just want to say, pad IDX equals 0. That's it right there. Pad IDX, where is that at here? Embedding pad IDX is this. So we put it there. Batch first, true. Oh, look at that. I could have used this. I could have used that. I didn't know I needed that. If we knew about this before, it would have been fine. Code Langtons, you like the music? Nice. This is free music from Google. This is called Thor's Hammer. It's on Google Studio Music. It's Creative Commons, I believe, so it's completely free and has no copyright restrictions on it. Okay, so where do we set this? So padding IDX is here. So we need to pass in, which we set to 0. So let's add that as well. It's not something that we need, it's just something that I want. Pad equals 0. And then we want to put that in our embedding. Whoa, Code Langtons! Thank you for becoming a member as well. Hey, what's your rate on membership? You've done that more than once, haven't you? You're like, what is this, like month 3? I can't tell. How many times have you done that? Thank you, Code Langtons. That's fantastic. Thank you for becoming a member for many months now. That's so cool. Well, you know, you might be the one that has the longest streak. You might just be the one with the longest streak. You have the best vibe. Oh, sir. Well, thank you. Appreciate it. Good to have you here. And I have my gratitudes for all the wonderful things. Okay, there we go. Got the music going again. I think you can see the number of months in the badge. Oh, right. So it's blue. It's blue. I forgot what the colors are. Oh, you're also blue. I think you can, yeah. So wait, what is so I need to pull that up real quick. I need to see. Pubnum Chat SDK looks awesome. Does it? It's been through many iterations. It's like on year 8 or 9 now at this point. It started in 2014 or 15. So we're year 9. We're about year 9 on that SDK. It's been around and it has been evolved multiple times. Yeah, I'm like slightly turquoise for 2 months. Nice. All right, I want to look this up. So let's go. Let's take a peek here. So we need to go to Studio. Let me do that real quick. New Studio, and then I need to see where it's at here. One moment. Where are we at here? Let me pull this open a little bit more. How do we do this? Here we go. I'm looking for where is it? Memberships. Here we go. Where is the levels? Levels, here we go. Not that. I need badges. There we go. Here we go. All right. Here's the badges. All right. So blue means new member, teal first month, and then a turquoise for 2 months, and then yellow for 6 months. Nice. And we can customize these. We can upload our own. Right now we're just using the defaults because we have things to do throughout the day. And that takes, I suppose we could take our time and sit down and really customize something. We really could. Do you also see the normal boot screen? That's actually, you posted this morning. The normal boot screen? Where is that at? Where are we at here? Right here. Whoa, I missed this. I missed that. That's a pretty good boot screen. That it is. That's a pretty good one. That's pretty fancy. That's pretty fancy. I come from the age where the boot screen logo was just a bunch of pixels on the screen and it was static. That's the era I come from. You had some OPSEC burnout, so you got out of the internet because of oh no, you went to hospital. Oh no, and now you're back. It's all good. It's good now, and you have time off the internet. Hey, that sounds like relaxation is necessary. Hey, Clips Merge, good to see ya. Clips Merge, we tried something today, didn't we? We tried something and it didn't work. Steven being old, I know, right? We're in the old now. All right, so let's say, how do we do this? Was this right over here and here? How do we do this? In the embedding layer, we need to, no, not the, yes, the embedding needs to be padding IDX. Okay, let's try it. So padding underscore IDX equals pad. I'll say pad IDX right here. We'll update that right here. There we go. There we go. Chat SDK is all client side, 100%, yes. It's 100% client side, you got it. You can use it on the server too, probably. You definitely could use it on the server. I'm pretty sure. Hospital is an interesting place. It is usually a place you don't want to be, for every possible reason. Any reason you don't want to be there. Well, I mean, one is a bunch of fastly changing PNGs. So basically it's the same. Okay, Jinlu. All right, so it's the PNG that's just a bunch in a row. So it is a big PNG, and it's probably just, moving the window across the PNG. So it's what do you call that? I don't even know. It's a sprite. It's a sprite that you've animated. You had to buy Schedule 1, so which ways my friend was wasting it for me. Wait, that Schedule 1? What does that mean? Are you talking about prescriptions? It's an interesting place when you have... Oh, yeah. If you have a tax like that, I think it might make it worse, right? Does it make it worse? You shouldn't want to be at a hospital unless you're a doctor. That's a good point. That's a good point. You shouldn't want to be there unless you have like a passion for healing people. Let's put it that way. All right, you guys. So I think this will do the trick. It's automatic, and I think it'll automatically work, no problems, right? Hey, nice. Check that out. We just completed one of our to-dos. Or is it going to learn? It is learning. Okay, it's learning. All right, we're good now. Good. The game Scheduled 1 is about making a bad medication. Oh, Empire. So your friend was waiting for me, so I had to buy it. Oh, okay. So it is about prescriptions, but it's a game. Got it. It is about prescription, but it's a game. Okay. The more we know. Are you doing embedding? Great, yeah. Hey, we sure are. Parkour. Parkour. Good to see you. Welcome on in. More like a passion for stealing people, cause look at the healthcare charges. Yeah. It's expensive. In America, it's expensive. Healthcare is very, very costly. And now insurance is expensive. And healthcare is so high because Americans mostly eat processed food and an animal product, right? So that's the staple diet for every meal in an American household is some sort of processed product and an animal product and very little healthy food. So that's why our medical bills are so high here is because we have voluntary illnesses that we have to deal with. More like a passion. Yeah, exactly. So we steal people's money. Whatever, fuel gone, but expensive as usual. It's expensive. It sure is. Well, everyone is starting with Ozempic. Hey, now that we got Ozempic. Exactly. Well, Ozempic just reduces your appetite. It slows down your digestion, and it makes it so you don't want to eat as much. That's all that does. So it means that you're getting fewer toxin, it's also absorbing all that processed food more slowly, which is better for your body and will allow your body to recover more quickly from those illnesses that you're volunteering yourself for. Are you someone who is volunteering yourselves for illnesses that you don't actually need? You probably are if you're eating an animal product and a processed product. Did you know that it's optional? You didn't, or you're opting in. You're opting into those illnesses, and you're like, but it's not my fault that it is. Technically, it is because you're making the choice. The timing of the music is immaculate. Yeah, the problem is people are eating all the bad things. Hence, you won't actually get your full nutrients. You're right. You won't. It's your choice. You're choosing to make yourself have those illnesses. It's your choice. Would you use the chat SDK for only visuals, basically, and then my other assets for transactional functionals or something? Yes. So the chat SDK gives you all of PubNub's APIs baked into a chat format. So with PubNub, you can send and receive data in any format, any pattern. You can design your channel topology in any way that fits your business. There are different use cases for PubNub. Delivery, notifications, gaming, multiplayer user experiences, collaboration, like for, Office, documents, updates, cursor movements. You can do a whole bunch of different things. And chat, right? Like live chat. That requires a specific pattern. What we've done with our chat SDK is we've implemented that pattern into code, and it leverages all of our APIs behind the scenes in an abstract way that makes it easier for you to build chat. Transactional. Exactly. You can hack it too if you want. You can hack it too. Okay, so let's start from the top again. All right, so we're going to build our tags, which is our output data. This is going to be tokens. So this is really tokenizing. So this is tokenize our output. There we go. Tokenize our output. We don't use this anymore, or do we? Build. We don't need this anymore. We don't need this. I don't think, right? I'm pretty sure we don't need this. So let's double check that we don't need it. We're gonna comment that out. Make sure it still runs. Okay. Hold the phone. What do we do here? Okay. Oh, we still, okay, hold on. No, okay. So I guess we still need this? Build dictionary character level. Oh, I guess we still do need this because we're still using the dictionary. Of course we still need that. Okay. Got it. Is there a bug bounty? I ain't hacked nothing. Oh yeah, a bug bounty. We do have a bug bounty. In fact, it's the same thing as all these other companies have been experiencing. Problems with submissions of bug bounties. It is now 90% of all of our support tickets are bug bounties because of AI. They find a bug, right? They're like, is it a bug? Find a bug. And they submit it to us. So yes, it's there. It works. You can do it if you want. Because we can interact with the stuff. Yeah, yeah, exactly. When we do some fun streams where we can interact with the stuff. Because the clip merge, yeah. I know what you're talking about. Those are fun. Those are fun. We'll do more of those. We'll do more of those. Bugs are a feature now. Exactly. They're a feature. They're expected. Hey, that's been there we depend on that bug. That bug has been there for so long. That bug has been there for 10 years. You can't fix that bug. If you fix that bug, it'll crash 10 other things because we depend on it. You can't fix that one. But yeah, we do have a bug bounty. We do. Okay, so we're still building this. All right, let me close that window. All right, let's vectorize. So we're getting the max length of our sentence, so that way we understand the dimensionality of what this is going to be. We need to know how many tokens we're going to have for every word and how big the sentence can be, right? We need max sentence length and max word length. Then we're going to go through a normalization step where we're going to split the words and lowercase them. Legacy bug. Yep, exactly. It's a feature and it increases website time. Well, yeah, it's a feature. We want our users to stay on our website longer, right? We want them to engage more. So even if it holds them back, right? It's a feature. All right, so I like this abstraction here. This is great. Oh, hey, how's it going there? What is JavaScript? Or are you saying JavaScript or JavaScript? JavaScript is a ECMAScript programming language. Very, very hard to get a bug bounty from client side of a closed source software. It is. People do it though. They still do. JavaScript is a programming language. Steven, guess the time. Is this made with or without AI? Right here, AI. AI. I'm saying AI. But you know what? I think it followed our pattern. Or you copy and paste. Nope, you did this. You did it. Nice. Not. Okay. All right. Very nice. Okay, so Neva, you took our multi-nested list comprehension, right? Our list comprehension, multi-nested list comprehension, and you normalized. That's so cool. That's great, Neva. All right. Some copy pasting, but no AI. Nice. I mean, I was like teetering on the edge. I was like, what do you think this is AI? I should have said you did it. There were signs that it was human. It was signs that there was human. I should have said it. Neva, nice. You love how you can tell it's kinda? I did. I was like right on the edge. I'm like, this is the thing that kind of looked like it was, but you copied and pasted this because AIs don't write like this, right? They don't. No AI would write like that unless you told it to. You held it to a fire. Remember my Python tutorial where you said it's hand-coded? It was AI assisted. AI assisted. Very nice. Just a smidgen of AI, right? Just a smidgen. This is great, you guys. Okay. Oh, how's it going? Solo Bolo Clips, good to see ya. Have you ever made a game? Is that a question that you ask people? This is a common question, it seems. Yes is the answer. I've made multiple games. They were fully playable, and I've not released any of them publicly, though. One was, a space shooter. One was an RPG. One was a sort of an action-oriented game that we did live on stream. We did it live on stream. Like, if you sit down and review, you think it's equivalent code. It's really good code. It's really good. Given a good review, you could do it. I think so. Yes. I think so. Yes. Kind of funny, like a quiz where you can have code displayed, and then each of us has to say AI or no. Oh, it's a good one. Did AI write this, or did a human write it? We could do that game. The thing is, code mandates certain structures for it to work properly, and you know what? It might be really difficult to tell if an AI wrote. Some things are giveaways. You would need more context. Like, see this on the screen? An AI would never do this right here, right? An AI would never do something like that. Also, an AI would never do anything like this. This is purely human written right here. These are two signs right here, here and here. Those two highlighted segments on the screen, definitely human written, right? I mean, the code comments, because it's commented out. Like, an AI would probably write this, like this code right here would probably be written in a standard for loop that is like right here, right? So that's what an AI would write. You'll train a model to write code in this style of Steven. Hey, you could also do that. That's true. I'm asleep. All right, sounds good. Clips merch. Enjoy your sleep. Thank you so much for the clips. Appreciate it. Wait. Yes, thank you for the clips. Can you show the game you made sometime? Sure. Do we even have it anymore? See, CD, Pytorch game? Did we do that? See, Pytorch data, no. Game, no. Python basics, Pytorch, Python tutorial. Maybe it's in Python tutorials. I'm just gonna see. I don't even know if it's here. Pytorch tutorials, and then we'll have to find it later. I don't know where it's at. Unfortunately, we'll have to find it later. What vector DB are you using for this? Oh, we are not using any vector DB. There's no vector DBs here. Not a single vector database, you guys. Although this is a case where we'd kind of want to use a vector database. So what we could do is our input data needs to be pre-processed, right? And we'd want to store all of our vectors somewhere. It doesn't need to be a database though. We just want to pre-process the data. It doesn't need to be vectors. I mean, it doesn't need to be in a database. Just some text file. The chase game. Yes, Torva, exactly. The chase game. We built that live on stream. So Torva just proved it. We're serious. We really did. We really built it. You found something kind of fun? Check in general? Okay. You think you linked it in the link share once. Let me look. Okay. Sounds good. Thank you for the hearts, you guys. Appreciate it. All right, Jen Luz. In general, what do we got here? Mac OS style boot screen. Oh, it's going to give you an Apple icon with a loading bar at the bottom. Hey!
Yeah, so somebody just made a macOS style boot screen, and I installed it. I don't know why. I'm not actually gonna use this.
There you go. All right, there you go. I see that. That's what my boot screen looks like because I'm on a Mac. Hey, Nike, good to see you. Welcome on in. Happy Friday. We made it to the weekend. I'm so excited. Apple is a fusion company, so this works. It counts. I mean, it works. Yeah, we did. We sure did. Okay. So let's keep going. I want to review all this code. So we finished this to-do item here. We got our token. Although I kind of want to set it to the mask, right? So let's do that really quick on our LSTM input. Let's do that here. And then I'm going to do this real quick. I'm going to make this pretty. Pad X equals dictionary. Was it word? The dictionary is letter, so we just say mask, right? Like that. There we go. That should do the trick. All right. Thank you for the hearts, you guys. Fashion as in clothing. Apple is a fashion company. Oh, I misread that. Oh, yes. Okay. So this works. It's a fashion company. You're right. They just, the aesthetics. Is it form over function? And Apple is mostly form because they design pretty UI, pretty graphics, easy user experience, and mostly the user experience optimized, right? So really good hardware. So it's mostly fashion. You're right. It's like really expensive. You're paying for the fashion. You're not paying for the hardware because you can buy the same hardware that's for half the price. Whoa, Nike, a lot of hand waves there. You're thinking about making something today that emphasize collaboration through precise component system via GitHub with the goal to watch the full project expand. Anyone else want to do that? I'm kind of curious what that is. You're thinking about making something today that emphasizes collaboration through precise component systems. I don't quite know what that means. Nike with the dab. Good to have you here. Like, think if you just architect the nodes, right, and lay down some basic structure, it could be cool. Oh, foundational components? That makes sense. You could do that. See you, folks. Okay, Code. It was great to have you here, Code LinkedIn's Entropy. Thank you for the super chat and for the membership. Thank you. Appreciate it. You were talking about this today? Nice. Steve and I just sent a GitHub repo and share. Oh, we can share the game. Nice. All right, let's do that real quick. Let's do the game share. All right, we'll do the game share and then we'll get back to our LSTM. Are you making AI? Yes, we are, Josh. We sure are. You can see here on the screen. We're walking through our LSTM. So we're walking through everything that we've built so far. This is our mask. Is that going to run? Let me run this real quick. Yes, there it goes. Okay, good. All right. Utility versus vibes. Yeah, there you go. Pizza or burger? Pizza. I'd go with pizza. To be honest, yes, a lot just comes from Samsung. I mean, they have even what to use the Samsung cameras. Now, even want to use the Samsung camera. Okay. Apple products are very much a status symbol. They are, aren't they? I mean, Android, there are a few Android phones that are like flagship, right? That are pretty statusy. Though I would say Apple is the leader in that. Yeah, in that aspect, they're the leader. Could be a game. Pizza or burger? Pizza. All right, let's go to our Discord really quick and go to link share. Here we go. Oh, this is it right here. AI game. Okay, so it was called, thank you, AI game. All right, let's see here. Let me go back over here, close this. Vi desktop AI. There, AI game with better art. We have to clone it, don't we? Okay, CD desktop. Git clone. All right, let's go into this. Thank you. All right, so the AI chases you. Let's copy this code and we'll run it to show you guys. And you'll see why we didn't release it. Pretty quick. Don't expect anything fancy here when we get this down here. Destination already exists. I thought we already tried CD desktop. Oh, we're on the AI game. Oh, it is already here. Okay. No, we do have to clone it. Okay. Git clone CD AI game. There we go. All right, Python. Game.py. Here we go. All right. So you guys, so this number is approaching 0. What is going to be on there? Solo Bolo Clips, what do you mean? What do you mean by approaching 0? I'm actually kind of curious. What do you mean? Hey, Los Pros, thank you for saying hi. Welcome on in. It's Friday. Nice instant text-to speech. Yeah! Basilisk. Good. Thank you. Can you translate it into Japanese? We could. Uh-huh. We certainly could. We are probably not going to do that right now, though. We might, though. You would consider a nothing phone to be a status symbol. Yeah, the nothing phones, they're mostly form over function, right? Especially with the lights on the back. Exactly. What's the LSTM approaching through? Oh, got it. Okay. Yes, so this is the loss. The loss is the error, which tells you how wrong the model is. So you want to reduce this number. You want the model to be correct. So when you're training a model, you want the loss to reduce to near 0 as best as you can. However, if you overfit on a model, it can't generalize on data that it's never seen before. So what you need to do is you need to test your model beyond the loss. You need to test the outputs for data that's never seen before and find when that number hits the best outcome. Once you do that, you want to stop before your model reaches perfect 0. Because if it reaches perfect 0, that means that it has total recall at that point, right? You've seen that movie, right? With Arnold Schwarzenegger? Total Recall. You're talking about building a collaboration exploration experience structured to take scripts from everyone with naming conventions to work as nodes in a larger connected project. Oh, Kyle, I might have an adventure for you. It might be a while before I can tell you about it. We might have something for you, though. In a couple weeks, it's going to get exciting. Solo Bolo Clips, got it? Nice. You don't understand any of this, but channel intrigues you so much. Hey, JM, good to hear it. I've been watching every day for almost a week now. That's fantastic. I'm so happy you're here. We can learn together. We are learning to become Pytorch experts. We are learning all of these things together. So I have a good foundational knowledge of AI and ML. Been doing this since 2014 and before the frameworks got popular. So you had to write everything by scratch from hand. I was pretty good at that. Now we have frameworks and they're very good. They come built with all sorts of algorithms ready for you just to pull off the shelf. The challenge is you have to memorize those patterns. So it becomes a framework that you need to memorize. That's what we're doing on this channel. And it's going to take, we're going to do a lot of it. We're going to do a lot. Something that's roughly entropy. Let's see here. Trying to catch up with the chats here, you guys. That movie was awesome. Yes, it was. Total Recall, you guys. Total Recall. Like, technically, this is entropy times, I think, something like 1 divided by 2. Los Pros, should I add a command to your terminal app that goes to your YouTube channel? Hey, Los Pros! That sounds pretty nice. Yeah, you could do that. Only do that if you want to, though. Like, is it going to add value to it? Is it? I don't know. And probably not, but it's still fun, right? You could still do it. You got a commercial and had to rewind. Oh, yeah. Oh, did you? Wait, on a live? Google told me. YouTube told me. Wait, Kyle, can you confirm this for me? So, I asked this question to YouTube before. They told me that there are no advertisements for live shorts. Did you get one? Now you're super intrigued? Yes, we're going to do it. We're going to do what you described. Essentially, is what you described. And I'll tell you about it as soon as we can release it. It's literally learning a new language. Yeah, it is, JM. It's like learning a brand new language. You just a stream to follow, but you can do it in whatever way you want. Python would be perfectly fine. Yeah, there you go. You should visit Spain. Oh, Spain is fine. I think Spain's fine. Hey, Martin. Hey, Martin Inland. Thank you for the hello. Thank you for clicking the hello button. Good to have you here. Get ourselves a Martin Inland. Oh, a Solo Bolo Clips. You also clicked the hi button. Thank you. You're watching on desktop in horizontal view, and you're seeing it as 1080 by 1920. Yeah. Yeah, so Steven, the loss is entropy. Oh, thank you for... The loss is entropy. Okay, got it. So you want to reduce entropy in relation to the unit, which is basically similar to a bit, but based not to. Okay. Hey, Boris, what's up? What's up, Boris? Good to have you here. We're learning long short-term memory models is what we're doing today. We're going through the whole thing. And someone asked us to play this game really quick. Here you go, guys. All right, here we go. Is it going to run? Okay. This is our game from a long time ago. It's very simple. It is using Pytorch. So it's got levels, and you need to stay away from the big red dot. That's it. It's a keep away game. All you have to do is stay away from the big red dot. The big red dot learns to track you. So if you hold still and you see, I didn't have to move that time, but it's gonna know to find me. Like, it doesn't know how to do it yet, but it's learning. Oh God! Ooh. See? Oh, that's why I saw a commercial probably. Oh, got it. Okay. Thank you, Cal. That describes it. What is this Star Wars music? Jinlu? Well, I don't know. See, now the AI is getting a lot smarter. See, Jinlu, we made a game. We've made a game. It's not very good. It's not a very good game, but it's still fun. It's a stay away from the AI. The Skynet's gonna get us. Skynet's coming for us. Level 7's pretty hard. See, the AI, it's just too smart now. Like, it knows how to actually track us. Humanity lost. It's over now! Awesome usable utility. Hey, good luck giver takers. Good to see ya. Welcome back. Chilling reading open circuits. The inner beauty of electronic components. Boris, nice. This is you've joined the right channel. You joined the right channel. It's what we're doing here too. Well, we're doing computery stuff. Let's just say we're doing computery stuff. So that's the game, you guys. That's what we built. That's what we built on this channel. The name is hilarious, by the way. Is it? AI can't design yet. Well, it can pretend to. What's it called? It's called AI game, maybe? Here, let's close that. All right, so it is available on our Discord. Torva just shared it in our link share right here. It's called The AI Chases You, Run. That's what it's called. The AI Chases You, Run. I think you could Google this right here. Let's see if we can Google this. Is it gonna work? Let's see here. Well, not really. Let's say GitHub. Is it gonna show up? Nope, not even a little bit. Okay, so you can't search for it. Well, it's not really a big project. It's on our Discord though. If you want to curious to check it out, it'll work on your system. Do you want to speak to you in Spanish? Oh, Los Pros. Well, give it a try. I think that sounds like AI game. Exactly, Torva. It's called AI game. Link share in the Discord and in the link tree. The Discord is in the link tree too. Yeah. Okay. All right, since we did that, let's go back over to our Pytorch and let's see if we can wrap this up. Vale? I see you said vale, which means what? I don't know what that means. I studied only a little bit of Spanish. In volley? Okay. You can try though. You can try. I bet you I'd be able to understand a few things. Maybe a smidgen. You know who can speak Spanish is Todd, my co-founder, CEO of PubNub, Todd Green. We created this company called PubNub. And he is the CEO at PubNub. And he can speak to you in Spanish. Let's see, is Todd around here somewhere? Todd will be in the patents, I think, here. In the patent section. Where are we at here? Show all the patents. We should see Todd. Here we go. See, here's Todd. Here's Todd Green. Right here. CEO at PubNub, right there. Well, isn't that great? Yeah. Yeah. Que bueno, no. Yeah, well, isn't that great? I think it's great. It sure is. See, we can do a little bit of that. We know what you're saying over there. Something custom like that would be crazy. Scripting language. You could make a scripting language. I built my own scripting language before. So yeah, that's Todd, co-founder, CEO of Pubnub. Okay, let's go back up here. Bring this back up to the top. Here we go. All right. Let's get back to our LSTM now. We got to wrap this up. So what I want to do is I want to walk through all of this, all the ideas behind this. Let's walk through this. Okay. So we're building our tokenizer for our output. This is the target classes that we want. We're going to train the model to learn what different kinds of words are. We have nouns, adverbs, adjectives, verbs, things like that. We're going to train the AI to understand what those are. That's what we're doing. Lisp is cool. Boris, Lisp is weird. Lisp requires you to have a whole bunch of parentheses, right? Parentheses everywhere. There's no escaping the parentheses, right? So parenthesis, parenthesis. Oh wait, do you want more parentheses? Yeah, you do. Here's another. You want another parenthesis? Yeah. Oh wait, should we like do some indentation here and have some more parentheses? That's what Lisp is right here. There you go. Lisp right there. Lisp is right there. Okay, so we build our tags, and then we build our tokenizer, which is going to turn our letters into tokens. And that looks like this. Where's our train at here? Let's go over here. Los pros, okay. Where is this at? I want to only print out the first, so let's just do return on our first input. Here we go, perfect. And there we go. Lisp is fourth in reverse with heap memory instead of stack. Is it? Wait, I thought it was most. So wait, Lisp is fourth in reverse with heap. Oh, in reverse. So you're saying that it's performant in reversing lists? Is that what that is? Just installed Gemini CLI. Oh, nice, Jinlu. Gemini is fantastic. Fourth is a language. I should have known. I should have known that. So wait, Lisp is fourth in reverse. Got it. So Lisp is more heap versus stack. It's stack-based language. Oh, nice. Very neat. Very neat. Let's take a little peek at our fourth language. Let's see what that looks like. It looks assembly-like. Wince? Wince? Is that real? Wince? Pay wither. Oh, right. Okay. Fourth is a meme language, isn't it? You wrote an interpreter for fourth. Did you? No way. That's amazing. Have you tried this new AI in Terminal that can control your PC? I have not. I don't want to give it control on my PC. Fun C code with computed go-tos. That's basically what this is. No, it's real. Oh, they've used it. It's used in firmware. No way! Really? Dupe, then fill, wince, then reply, wither. Someone was having fun. Someone was having fun, you guys. It's a low-level scripting language that is used to be as fast as C. Oh, no way. Well, it looks nearly the same as assembly. It's just like one step above assembly, it looks like. So someone who knew assembly wanted to make a language just slightly above assembly. I mean, also that's what C is, to be fair. C happens to be better at for modern optimizers. Whether they built a bacon soon. Yeah, they'll build a bacon. Or is it beacon? No, they'll build a beacon soon with the wither. Oh, Minecraft. I know what you're talking about there, Torva. Minecraft, yeah? Wince? I know, right, Boris? Wince? It's old English, it sure is. Steven, you're looking at the horrible looking fourth code. Is there better? Is there better fourth code? Can there be better fourth code? Okay, hello world, okay. I think we're looking at just fine fourth code. That does not look like fourth. Let's see here. This is assembly. This is just assembly. Oh, hey Boris. Hey Boris, thank you for subscribing. Appreciate it. Welcome on in. You joined the right channel for software engineering. What we do here on this channel is we mostly learn how to code. We're gonna code by hand. This is the learning channel where we learn together, most recently to become Pytorch experts. That's what we're doing now. Thou shalt instead of if then. Yeah, exactly, Boris, exactly. Fourth usually actually, it's kind of clean. Never seen half of those things. It's pretty funny. I'm enjoying it. I'm entertained by it. I'm entertained by it. Would I use it? I don't know. I don't know if I'd use it. Okay, at least those look a bit more formatted. Yeah, a bit more. So that's assembly. This is fourth, right here. Fourth programming language. Here we go. Is there any code samples in here? Okay. Oh, it's Lispy. It's Lispy. Okay. Okay, there's some Lispiness in here. It's got closures. Nice. So you can return a function. Is this really fourth? Is this fourth right here? Huh. Okay. Well, it's a lot more traditional looking than I thought it was. Whence? Yeah, whatever. Well, we're running low on time. We do have to start looking at our code to fulfill our objective for today, because today's the last day of LSTM. You can have assembly inside fourth. Oh, got it. Okay, there's some inline assembly capabilities. Got it. Okay. The first thing you saw was assembly was fourth. Okay, got it. That example looked like kind of cramped. A smidgen cramped. Yeah, you got it. Trust me, look up open circuits, the inner beauty of electronic components. Okay, we'll do that. We'll do that. Let's do that. It's a book, The Inner Beauty of Electronic Components by Eric and Wendell. A 2022 book. Oh, wow, it's recent. Uses stunning cross-section photography to reveal the hidden art. Oh, yes. Okay, I saw a YouTube video of this. Because they have, this is sort of like a marketing trick where they use some of their scanning technologies. I think I saw this. Run out, never mind. Oh, we're good. We've got like a few minutes left. We've got about 7 minutes. That's plenty of time, though. That's plenty of time. 7 minutes left. Don't go anywhere. We're almost done with our LSTM. It's crazy expensive, is it? Let's see if we can buy it. Let's see here. Let's see if we can buy this. It is $27. That's not too bad. That's not too bad. Right? I've seen books more expensive than that. You have the PDF? Oh, nice, Boris. Nice. Peter Slow. 7 minutes, more like 20 minutes. Exactly, Torva. Exactly. All right, you guys. So we're going to lock in now. We got to lock in. I must have been thinking of something else. Hey, Peter. It's always the case. You'll buy the physical eventually. Nice, Boris. All right, let's go through this. So we build our tags. We build our tokens, which are our characters. You can see here on the screen what I'm talking about. That's what all of our features and labels are. This song's a good song. We vectorize. Vectorization is going to be converting using our dictionaries that we built, right? So we built our dictionaries right here. We got a dictionary. And let's pull this up here for a second so you can see that. Dictionary and tags are numbers. So it's a lookup. So we've got a mask that's 0. Letter T is 1. H2, E is 3. Our tags are going to be verb, determiner, and noun. We're keeping it simple. When we want to build our dictionary, that is this part right here. We take all of our training input data and we convert it into characters to encode it into a token. A token is going to be a number. Same for our output tokens, our tags, which are going to be the classifications. These are our labels what it's going to be used to train the model on our target outputs. We vectorize, and our input data is turned into numbers. So you can see here, we've got a sentence, we've got 3 sentences, and each sentence has multiple words in it, right? So you can see here, let's see here. Let's go up here. So describing that really quick. We have 5 words, and each word can have 7 words per sentence, and each word can have 5 letters. That is the dimensions. So it's a 3D view. It's a 3D view. So we've got our batch, we've got our sentence, and then we've got our word and the letters inside of it. So that's what it looks like. Lock in, Boris. Yeah, we're locking in. Describing that. So that is vectorization. We calculate our labels, target output, our features are the input, which is the data that you see here on the right side of the screen, right over here. This is our training data, sample data. So this is why we have 3 arrays, 3 3-dimensional arrays, right? So you see, right? So you see here, this is the second sentence right here. And that is the crow fly to water, right? The crow fly to water. So you can see the first word, THE, is 1, 2, 3, easy, and so on. As you can tell, this sentence is short. So the final 2 words in our sentence are zeros. So those are 0 pads. We've updated our LSTM tagger to include that tagging for a pad value, to ignore that. So we use that value here in our embedding, so that we ignore this padding. When we run it through the embedding, it will create an output that's pretty fancy. Let's do that real quick so we can print our output here. That's going to show what our embedding is. Let us return here. Perfect. So we're going to see one of our embeddings. Here's our embeddings. You can see we got some zeros down there. We got quite a few zeros. We got more zeros than I was expecting. What happened? Wait. Did we mess this up? Why is it 0 now? Is this our... Oh, because we added our pad for 0. Otherwise, it's going to give us meaning. Okay. So you remember how we had our pads before? So now it's going to 0 them out. Zeroing them out allows the model to not attend to any of these things. It's not going to pay attention to it because it's 0. So when it activates any of the neurons, when we're running on these, it's just not going to give us any output for those. This sentence right here, or this word, is going to have everything because it's full. And that is our final sentence input here. As you can see, it includes all 7 words. 1, 2, 3, 4, 5, 6, 7. There we go. Easy as way. So let's continue onward. Okay. Then we put our embedding into our LSTM. Our LSTM is going to have 2 outputs. It's going to continue to have a hidden state internally to track what it's seen previously. So that's important. The LSTM is different than all other kinds of layers. It's different than CNN. It's different than a linear layer because inside it's going to keep track of data that is seen previously, and it's going to use that data every time it gets new information. So as we pass more data into this model, it's going to use that information that it's seen previously in a hidden state inside of this layer here. And you can see what that is. So you see how we have an underscore right here? We're ignoring that underscore because we don't need to actually, if we wanted to look at it, we could. We're not going to though. And then we have a second LSTM that's going to convert from our letter to a word based. So it's, the way Neva wrote this is to sum all of the letters into words. So our output's going to look a little differently, right? So print output here. There we go. Print the output. And let us do Python full. See what that looks like real quick. Okay. So now you see a little bit. This is one sentence. This is just one sentence. So you see 1, 2, 3, 4, 5. I see 6 in there. I see 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, which is the length, the maximum length of our sentence. So as you can see here, we have 7 words in our sentence. That's 7 words right there. 7 words right there. McGray Hill, Patience Hall, Singarg. Wait, what is this? Pearson's, O'Reilly, CRC, Taylor Francis. Many are impossible to find elsewhere. Only a handful are worth supporting. You have all of the McGray Hill. What is that? At that point, it's 1WX because of the shape. Yes, okay. Steven, use dot shape. Okay, we'll use dot shape. Let's see. Print and print. There we go. We're going to print out the shape, you guys. We're going to print out the shape. All right, here we go. Printing out the shape. So you can see how that changed from 756. Oh, it's 6 because of our embedding dimensions. Right, okay. Because we set embedding dims. Oh, wait, our hidden dims are 6. Our hidden dims are going to be the output, which would be here. Yeah, okay. That's why it's 6, okay. So that's why we get an LSTM output of 6. 7, though, for the word, the maximum word. That makes sense. 5 for the letters. So we took the letters dimensioned and we smushed it into one dimension. That makes sense. Jinx. Yeah, the jinx there. Publishers. Oh, you guys. 7 words, 5 characters, 6 dimensions. And now you got 1 sentence, 7 words, and 6 dimensions. Hey, there we go. Yep. 7 words, 5 characters, 6 dimensions. 1 sentence, 7 words. Yep. There you go. You have 1,165 books. That's a lot of books. Where'd you get those? That seems like more books than a human would normally have. So that is the change. And then we throw that output through a linear layer, which is a fully connected layer. And that's going to be additional parameters, which is going to hold more information really about, this is the part where people say we don't really know what AI is doing. Well, it's more parameters, more if-else statements in a giant dense array. And it's going to fully attend to 100% every output from the LSTM into the linear layer. 100%. And then we're going to activate that, which is going to shrink the outputs into between 0 and 1. So if we print this output here, we'll see an output. Every single value between is supposed to be between 0 and 1. What's going on? Hardcover or PDF? Exactly. Hey, Aziz. Yo, Steven, do you know hexagonal architecture? Hexagonal? Yes. Maybe. I don't know. It's probably safe for me to say no. Though I might be familiar with it. That might be something. I couldn't tell you. If you asked me to define what that is, I would say I don't know. However, I might already be familiar with the concept. I've run into many things throughout my old age, you guys. My old age. Okay. So this, it's log. Okay, right. So this is log softmax. Okay. So that's why. Okay. What if we did 0? Let's see what's in 0. Let's do 0. What if we did -1? And it's going to give us, not very much. You want to do it on 1, I think, here. To get some... Nah, it's fine. Doesn't really matter. They look all the same to me. Okay. So what I want to do is, I want to see what the output is before the activation and after the activation. Here we go. So you've got your before and you've got your after. It made it bigger! Oh, it scaled it. Very odd. Okay. I'm not used to this style of activation. I'm just not. I've never used log softmax backward before. I've never used log softmax before. On your tablet, what are you mastering Pytorch? Yeah, exactly, Pedro. What you intend to do with it? We're going to create some fancy, fun things. I don't know what it's going to be yet. We are, though. We're going to build something fun. We'll be able to gather all of our data, whatever it's going to be, whatever our data is, and we're going to run it through a model that we built. Okay. So we are building our dictionary, building our tags, right? We're tokenizing them. And then we're going to vectorize using these dictionaries and tags. We set a fairly low learning rate. Here's our LSTM that we just walked through with a mask of 0, which is what we defined earlier. He's going to torch some stuff. Exactly, Peter Slow. Exactly. What does your company provide as a service? Aziz, good question. PubNub, we deliver live interactivity that your users want. So this is live stream, in-app chat, fitness apps, real-time updates and delivery drivers. We can do everything. We do it all. So stock quotes, updates, securities, things like that. Call centers with support tickets, chat with your support agent, transportation and logistics, where you see an order coming towards you at this very moment. Gaming, when you play with multiple players on the internet. Sports media, where you get updates live in real time. And gaming. Have you ever played a game on the internet? Well, you know what? You might have used us and you didn't even know it. That's my technology. So that's what we do. It's a sort of like a communication API for multi-device experiences. That's what we do. Communication for multi-device experiences. This music makes you seem like a mad scientist. He is. We could be. There's no way for you to know. We can be completely mad. We've got a criterion, which is our negative log likelihood loss. That's our NLL loss. Our optimizer is SGD, stochastic gradient descent, with a learning rate, standard learning rate. No momentum is defined, just a standard learning rate. Said love. Oh, hey, said with love. Thank you. Thank you. Appreciate it. All right, I'll take that as a compliment. And then we just start training the model. The easy part is the model. The hard part is the data preparation. So we're vectorizing our data. We're converting them into tensors, which Pytorch wants, right? It wants tensors. We're going to print those out for debugging purposes. We're going to train over the data set for the number of epochs that we're looking for. In this case, it's 30,000 epochs, which is more than you'd ever want. You don't typically want 30,000 epochs. Maybe like 100. That's probably something you'd be more interested in. And then for all of the data samples, which are going to be our sentences, you see right here. So we've got 3 data samples, 3 sentences. We're going to loop through and do each of these. We're going to snag out one sentence at a time. So this is the target labels, and this is the sentence itself, right? So your sentence and a target. Our model is going to store gradients. We need to zero those out, so that way when we pass through do a forward pass on the sentence, which is our function here that we've defined right here. This is our forward pass. Then we are going to change the shape a little bit of that output. We need to do that because our criterion, negative log likelihood loss, is expecting a very specific shape to match with our target, right? Then we backpropagate to calculate the gradients, which are going to be matrices that are going to apply parameter updates to our model layers right here. So we get an embedding layer, LSTM layers, and a linear fully connected dense layer. When we run optim.step, it's going to use our stochastic gradient descent optimizer to apply the gradients that are calculated here. Calculate gradients for learning. The learning is going to say, when we get our delta for the criterion, this is going to calculate the loss, which is the error. How wrong is the model? Neva says this is the entropy. Entropy. There we go. The entropy. You want to reduce these. You want to make them as low as possible. So when you're calculating your gradients, it's going to give you 100% perfect value for that one data item. It's going to say if you apply the gradient 100% to all of your model weights, it will learn that one sentence perfectly instantaneously. One calculation pass required. Do you use Beautiful Soup? Beautiful Soup is a tutorial. Is it? Wait, what is Beautiful? No, what is Beautiful Soup? I forgot. Beautiful Soup. It's a Python. It's from Python, right? Something Beautiful Soup. A popular Python library for parsing HTML and XML documents. Oh yeah, widely used for web scraping because it creates navigable parse tree that allows developers to easily search, navigate, and extract the data they're looking for. When they capture that website, they need to be able to parse it and capture data that they're looking for. Beautiful Soup lets you do that. How long left on the stream, Stephen? Well, we're over time right now. I wanted to lock in and walk through the 100% of the model, which we basically did. So we got the delta, which is the error, the loss, the entropy. We're going to calculate the gradients based on that loss, which is going to give us a perfect output. However, we don't want to put 100% of that value into our weights in our model, because if we did that, it wouldn't be able to learn anything else. So we have to slowly apply the learning over time. That's what the optimization step does with our learning rate. So we have a low learning rate. It's going to multiply that gradient by our learning rate of about 2%, right? 2%. It's going to take 2% of that learning value that we found, and it's going to apply it to those weights. And our weights are our layers right here. Boom. That's it. And we do that in a loop, a long loop, until the model learns. You want to see what that looks like? Let's run it. Let's run it now. Let's see, print right here. We're going to comment some of these guys out. Yeah, we'll comment these out because there we go. Okay, perfect. So let's run that now. Python full LSTM, and it's going to start learning. Oops. We forgot to print the output. We need to print this right here so you can see it learning. Okay, here we go. So it's going to be a big number above 1, and you want that number to start dropping. Ideally below 0 or below 1. You want it to be below 1, right? And the lower you can get, the better, especially with a large data set. However, you don't want it to reach perfect 0 because then it hasn't generalized, potentially. Have a great weekend, brother. Mark Lemon, you too. We did it, you guys. We went through the whole thing. How did you come up with the model architecture? And how do you usually choose the architecture? It depends on what your input data is. So if your input data, thank you for the hearts, you guys, appreciate it. Good to have you here. So your input data, is it going to be an image? Is it going to be text? Is it going to be like classes, right? Like categories of things? Like you might have a spreadsheet. On your spreadsheet, you might have a bunch of rows that have classified things with certain tags. So your input data might be tags, right? So what you need to do is vectorize your tags in a way that you need to tokenize them by value. You need to assign an index, and then you need to convert that index into a number between 0 and 1. When you do that, that's going to allow you to define your model. Typically, dense linear layer is all you need for that. For classical machine learning and AI and deep learning, you don't need anything beyond a single dense layer. For something where you're using words, you will want to use an LSTM or a recurrent neural network or a transformer because it has sequence, right? So those are the models that you want to use for sequence oriented. In the documentation, it says time is a factor. Send 100 joules. Whoa, Boris, thank you. Appreciated. So glad to have you here. Thank you for the 100 joules, or for the 2 joules. Sorry, you sent the 100 for 2 joules. The 100. Appreciate it. For an image, you want to use a CNN because it's going to give you representation of multi-dimensional data as proximity. So pixels, right? Pixels on the screen. You want to be able to use pixels on a screen to calculate meaning. So pixels that are near each other, right? So you can say these pixels right here are near each other, right? These 4 pixels. So with those 4 pixels, you want to calculate them together. So that's what a CNN is, through a bunch of filters. So you can do things like shape detection, faces, people, objects. Love the content. Jano, well, yeah, absolutely. Thank you for saying that. We're wrapping up here. We're just kind of getting to the end of stream and just answering some questions. So we just finished with our LSTM. I'm so excited that we did that. That's something I've wanted to do for many years. I've never done it. I never needed to. I've gotten close to needing something like that. Most of my projects, though, perfectly fine with just standard linear layers or some sort of variation on that. Those are the basics. There are other models and other patterns that are available, though for the most part, most data fits into those. So you've got images, videos, right? Images, videos, or text data where sequences matter, or just tagging, right? Tagging input. There you go. That's it. Have a great weekend, guys. Learned so much in the past couple weeks. Zergil, me too. All right, we're wrapping up here, you guys. Had so much fun. See you guys next week. We'll be live on Monday. Same time next week. Learn more than 5 minutes than you learned in your week at a job. Whoa, Peter Slow. Hey, well, that's great to hear. The nourishment of the thought is indeed most plentiful this day. May thy all spirits remain enriched as thou shalt venture forth. Also, liketh and subscribeth, everyone. Torva, thank you. It's good to have you guys here. Had a lot of fun. I'll have a great week. And bye, Steven. Bye, Neva. Good to see you. Bye, Torva. Bye, Jinlu. See ya. Peter Slow. Had a lot of fun. Good to see you, everybody. See you, Jano. See you, Zeus. Boris. Neva, of course. Jinlu. Yep. Mark Lemon. Everyone, good to have you here. See you next week. Bye, everybody. See y'all Monday.